Hello, everyone. I am Manoj Kumar. I work in Mulia as a Vice President for Technology Stream. I work at the intersection of what I call a software quality, engineering, and the modern testing strategies. And over the last few years, a big part of my focus has always been understanding how quality changes, let's say when software stops behaving in a predictable way. A lot of our traditional testing thinking was built uh, for deterministic systems, but the products we are building now are increasingly AI driven, retrieval driven, context aware, and a lot probabilistic. So, in this talk, I want to explore what that shift really means for software quality, testing, and trust. Uh, Please do scan the barcode if you want to connect with me, be in touch. This is my LinkedIn. To begin with, for a long time, the software gave us a comforting promise. Same input, very clear, and same output. That promise shaped how we built software, how we tested it, and how, if I can term it, how we trusted it. But today, more and more systems no longer behave in that fully predictable way. They generate, retrieve, rank, recommend, adapt, and sometimes even decide what to orchestrate or what to execute. So there is a big shift, which I want to talk about today, that we are no longer only testing software that executes logic. We are increasingly testing and going to test the software that produces behavior. So, uh, just to emphasize, we are not just testing code anymore, we are testing behaviors. What changed? The world, most of us grew up, the world I grew up, as testers, engineers, product teams, UX, UI, everybody was built on determinism. Logic was explicit, uh, rules were visible, outputs were predictable, and uh, um, if the calculation was wrong, it was wrong. If the workflow failed, it failed. Testing worked beautifully in the environment because we could define expected outcomes with confidence. We could automate assertions, repeated assertions, regressions, and create repeatability. That model gave us, if I can say, a lot of strength, um, because software itself was stable in the behavior then. Now, the old world rewarded precision because the system itself was precise. What changed? Now, we need to look at what has happened. Now, think about products we are increasingly building. Support assistants nowadays interpret questions. It's almost everywhere. Everywhere you find these things. Search systems rank results. Recommendations engine predict relevance. AI copilots generate responses. Agents choose paths. Even outside generative AI, if I have to say, more and more systems are influenced by probabilities, context, dynamic knowledge, and of course, the ever changing data that we have. So the shift is not only technological, it is behavioral. Software is no longer just executing instructions we wrote previously, it is increasingly producing outcomes that are inferred, assembled, and ranked. So, what can we emphasize on this slide? Modern software is just not coded. It is inferred, retrieved, ranked, and generated. Now, just to go deeper, what is the difference? What's the thing that can be classified within our boundaries of deterministic versus non-deterministic systems? In deterministic systems, same input usually means same output. We discussed this. It's a very clear foundation. That actually brings in a lot of perspective. That makes correctness easier to define. Whereas in the non-deterministic system, the same input, or if I can add to it, the same prompt can produce different outputs. Sometimes multiple outputs are acceptable, which are correct. Sometimes one sounds fine, but subtly risky on an edge. That means now, what's the change that's coming? Now the correctness becomes more contextual. We are no longer only asking whether the answer is exact. We are asking whether it is relevant, grounded, safe, useful, finally trustworthy. Right? Now, what are we emphasizing on this slide? In the old world, correctness was exact. In the new world, correctness is contextual. Let's move ahead. What's the illusion that breaks teams now that we're going towards the non-deterministic system? A lot of teams struggle here. I've seen it. We've been part of that. Not because they're weak at engineering, but because they're using the old quality models on the new system behaviors. The business still asks, did it pass? Did it fail? What's the percentage of pass, fail? What happened? How many test cases ran? Engineering, of course, will still need clear regression logic to be in place. The QA still wants expected outputs on all the use cases that has been produced. But the system itself has changed, right? When we force binary testing onto probabilistic systems, we create false confidence. And false confidence is much more dangerous than visible uncertainty. Now, if I have to emphasize on this slide, I can say the biggest risk is not non-determination. The biggest risk is pretending it behaves like older software. Moving on, now it would bring a question in all of your mind saying that what is correct? What correctness means now? Is there a definition for it? Let's take something simple. A chatbot may answer the same question in different but valid ways. A retrieval system may surface different relevant documents. Let's say an agent may complete the same task through different paths. Now, what does that give you? It gives you that the correctness now it includes relevance. It includes factual grounding. It includes consistency. Of course, how can I forget? It includes safety. Now, it finally can be said that it includes whether the system knows when to stop, ask, or defer. That is why the traditional pass fail language starts becoming too small for intelligent systems. Again, if I have to emphasize on this, accuracy alone is too small a word for modern software quality. Moving ahead, what do we call, where does the non-determinism really comes from? One common mistake I have seen, I've gone through, this is very common too, you can look it up in Google, LinkedIn, is blaming the model for everything, the model for everything. But many times that if you go deeper, the variation does not come from the model alone. Yes, model can be a problem, but it's not the one. It can come from the prompt, the retrieval. It can come from stale content, chunking. It can come from the ranking. It can come from tool invocation. It can come from user context or orchestration. So when system behavior changes, the right question is not just what did the model do? Change the system around it. So what is the new quality question here? This is where the quality question changes. The old question always was, still many believers, does it work? The new question now is, how reliably does it behave within acceptable boundaries? Wow. How reliably does it behave within acceptable boundaries? That is much more mature way of looking at intelligent systems. We need to define boundaries for acceptable behaviors, thresholds for confidence, like 10%, 50%, 90%, and patterns that based on this, there can be a risk that can happen. Again, we need to know what good looks like, what is weak here, and what can be dangerous. So, what it defines as, that I want to be clear here, traditional testing is not going away. You still need to test workflows, period. You still need to test business rules. You still need to test APIs, permissions, calculations, integrations, performance, reliability. But the moment the product contains an intelligence layer, the AI, that layer needs additional evaluation methods. So that is not a replacement story. This is an expansion story. What can I emphasize on this slide? We do not need less testing. We need a much bigger, clear definition of testing. In deterministic systems, a test case is often enough, right? In non-deterministic systems, a test case alone is not enough. We need scenarios, we need evaluation dimensions, we need SME expert reviewed expectations, we need semantic scoring, we need patterns, identification of variety of patterns, we need trend based regression, not just the step based regressions. So now quality becomes less about single assertion and more about an evaluation system that can observe behavior. You're no longer verifying output, you're measuring behavior here. I've been talking things. Let's just take a simple example of this. Take a policy or a booking question. A traditional system may simply show a policy page. That is limited, but low risk from interpretation standpoint. Now, what do? You replace that with an AI assistant. The AI assistant now summarizes, interprets. It sounds much smoother, professional with the way that it needs to know the persona. And it also gives a perspective that it's much more useful to the end user. But now it can also over compress nuance, miss exceptions, or even answer confidently in the wrong direction, right? The experience gets better, but the risk surface becomes much more larger. Look at the same example. Can I cancel my booking after 24 hours? The traditional search just shows the policy. Now, AI assistant, there it interprets the policy. It can show the right, it can show a variable right, it can show a corner case, and it can show something which is absolutely not necessarily the right answer here. So, what's the big thing? What's the hidden backbone here? One of the biggest shifts in AI system is that knowledge quality becomes product quality. If the source is stale, the answer can be stale, will be stale. If the source is incomplete, the answer again, quote unquote, can be incomplete. If the wrong document is retrieved, the answer may sound polished, fantastic, nice, but it can still be wrong. If your knowledge structure is poor, trust suffers at the user level. So we cannot test only the interface or the model output. We have to test the knowledge backbone. Now, if I need to again emphasize on this slide, if there are broken sources, it leads to broken answers, which actually leads to broken trust. On that front, why does a release confidence in non-deterministic systems become much more harder now? A release can be technically stable, behaviorally unsafe. Latency can be fine, deployment perfect, clean, everything ran. APIs 100% healthy, nothing may be crashing, and still the quality may have declined in the ways users actually experience it. The system may be more fluent but less accurate, more engaging but less compliant, more complete but less trustworthy. That means release confidence now has two layers: technical stability, which has always been looked up, and behavioral quality. That's the most important part. A stable system can still produce unstable trust. Understanding this, what the big influencers, the leaders, need to unlearn. I think leadership teams need to unlearn few assumptions. First, if it passed testing, it is safe to release. In non-deterministic systems, not always. Second, if the model is good, the product is good. Also, not always. Third, if users like it, it must be trustworthy. Good demos are not enough. POCs are not enough. Strong models are not enough. High engagement is not enough. We need better evidence for trust. User delight is not the same as user safety. What does the team needs to do now? Now that there are many undeterministic systems and every system just give some more time is gonna become one way or the other non-deterministic. What should the teams need? So what do teams need in practice? They need golden data sets. They need high risk scenarios. They need expected outcomes reviewed by people who understand the domain. They need semantic evaluation. They need source quality checks. They need comparison across versions. They need monitoring after release, not just before release. This is not just tooling, this is an operating discipline for intelligent systems. The winning teams will be the ones that operationalize trust, not just intelligence. It's been a cliche for some time. Is AI going to take up all the job? Is AI going to do everything? What is LLM as a judge and stuff? Does it reduce the human roles? A lot of people assume intelligent systems reduce the importance of testers or quality professional. I believe the opposite, complete opposite. The human role becomes much, much more important, but it changes. Humans now become evaluators of ambiguity. They judge for relevance. They are the designers of risky scenarios. They are the interpreters of behavior. They are the partners to product and domain teams in defining what acceptable trust actually means. So, this is not at all a smaller role, it is a much more strategic one. The more probabilistic the system becomes, the more valuable human judgment becomes. If I had to summarize the shift in one phrase, I would call it confidence engineering, not just finding bugs, defects, not just executing tests. Confidence engineering, because now the goal is to understand uncertainty, define the acceptable boundaries, measure the trust, and continuously validate the behavior of how the system's been evolving. That is going to be a very big mission for software quality. Software quality is now honestly a more important one. If I can emphasize on this, quality is now moving from defect detection to confidence engineering. We are a world where software will increasingly respond, infer, retrieve, rank, generate, adapt, and even decide. Now that makes the old shortcuts of quality much less useful, but it does not reduce the importance of quality. It increases it. The teams that win will not be the ones that pretend uncertainty does not exist. They will be the ones that learn how to engineer trust around it. The end of deterministic software is not the end of quality. It is the beginning of a more honest one. Again, finally, we are not losing control of software. We're being asked to reduce or redefine what control means.